This conference will now be recorded.
My name is Les Fox. I'm a Principal PWA Design Engineer with Atkins CRSA, and I was the PWA CRE, Design CRE on this particular scheme. And my co-presenter, John Hayes, will do a little bit of the talk later on. He was the engineering manager on this scheme. So this talk really is mainly focused on the track remodelling that happened at Peel Port. I'll just switch my camera off actually.
You've muted yourself, Les, instead of turning your camera.
Sorry, failed at the first hurdle. Yeah, so we're mainly focusing on the track remodelling works for the port expansion, but we're also going to look at, just to put it into a bit of context, how this fits into the UK strategy for renewables energy, and also we're throwing in a little bit of history about the railway at the port as well, just for a bit of interest. So target duration about an hour, hopefully, including the questions and answer session at the end. Okay, so this first slide here is just showing the move to renewables over the last couple of decades, and basically you can see there the trend moving away from coal and increasing reliance on renewables, which actually accounted for 47% of total UK energy generation last year. The biomass at Drax, which is what this scheme is all about, actually accounted for 12% of the total renewables generation in the UK. Yeah, so looking at this one here, so moving forwards into the future, there's a target for the UK for 50% of the energy generated by 2025. And increasing to 80% by 2050. Is that 2050? I can't see it on that slide. Yeah, by 2030, sorry. Okay. Right, just a quick mention about COP26. As everybody's probably quite aware, it's all been in the news last month. So this project falls quite nicely hand in hand with the themes of COP26, so it's quite a relevant talk to have at this time of year. And just to recap on the key outputs from COP26, and just general themes that were discussed and agreed: basically end deforestation by 2030, a 30% cut in greenhouse gases, that's mainly methane, by 2030. UK industry has to demonstrate by 2023 how they're going to meet net zero carbon, and over 40 countries pledged to quit coal completely to meet the net carbon targets by 2050. And the word pledges of financial assistance for developing countries to fall in line, sums of £1 billion talked about by 2023. So they're the main sort of outcomes from COP26. Right, this slide here shows a then and now sort of impression of the railways around Port of Liverpool. So the diagram on the left there, this is taken from Rail Maps Online. You can see there's a maze of industrial railways around the Port of Liverpool and Birkenhead docks there as well. Feeding all the various docks right the way up the seafront at Liverpool. And if we look at the diagram on the right, you can see that today, actually, the railway at Port of Liverpool is basically, if I just point to it, it's this little spur coming off here. So basically, that part of the railway and the link going up to Seaforth Container Terminal, that is it. So you can see it's a vast reduction in railway compared to the heyday there at Liverpool docks. I think that this basically rationalisations happened throughout the decades. That there was a large emigration from Liverpool between 1890 and 1930. 9 million people emigrated from the UK, to the Commonwealth countries and North America. 1919, Cunard moved their HQ from Liverpool down to Southampton. So, you know, since sort of pre-war years, it's been on a steady decline really in Liverpool until we've ended up with the rationalised track layout we've got today. Right, this is an aerial view of the site area that we're concerned with. So we've got the Bootle branch coming down from Edge Hill direction under Derby Road, comes around a very tight curve here on the former Regent Road level crossing. This is Regent Road Highway, which runs right the way through the site. It used to be a public highway. It's now just purely a port road, so there's no public access to that, but this was a public level crossing at one time. So the railway crosses Regent Road and then travels along in a straight alignment. This section of track here is actually single track, whereas the curve, once around the curve, that branches out into double track, and on the Bootle branch all the way pretty much to Edge Hill. So the project was really focused on double tracking this, which I'll move on to later. And then in the port itself, there's really three main groups of track here. We've got European Metals Recycling, which use these sidings here, and they actually load scrap into this dock, not into the dock, into vessels berthed in that dock. Then we've got the biomass facility, which this is the former coal handling facility here, which has been converted in recent years to handle biomass. There is no more coal traffic from the port these days. And then the track goes on off to the left here to Royal Seaforth Container Terminal. Right, this is just a schematic of the track layout, same orientation as that previous slide. So you've basically got Seaforth Container Terminal on the left here, three sidings for multimodal traffic. And there's a long connection back to the Bootle branch. Then we've got the Biomass Terminal consisting of the hopper and a road that goes down here to the dock. And then there's the European Metal Recycling Terminal located there. And I've circled in red the area that we're interested in for the track remodelling. Right, just a brief history of the port then. So going right through our site was the Liverpool Overhead Electric Railway. It's quite an interesting railway. It was opened in 1893 as a lightweight metro, transported tens of thousands of workers to the docks up and down Liverpool every day. So all the docks down here, obviously before the days of mass ownership of motor cars, people had to use public transport. So this metro system was crucial for keeping the docks going. It finally closed in 1956 after 63 years of service. The total line length was 8 kilometres from Herculaneum Dock all the way up to Gladstone Dock here. And just a few sort of facts about the railway. It was the first electric overhead railway in the world. It was the first automatic signalled railway using colour light signals and electric multiple units. And at the time of its closure in 1956, it was actually the second oldest metro system in the world. Right, here's an extract from an old Ordnance Survey map. So we can actually see generally that the railway that's there today is still sort of through the main spine of the site, denoted by the thick dashed line, if you like. But there were a multitude of other sidings that have since disappeared, feeding into Gladstone Dock and Hornby Dock, which has now actually been infilled, that one. And then a whole load more railway sidings over to the east side. Those have all gone. That's when we were involved in the project for the track doubling, that was actually all being developed as a new warehouse site. And just got a few historical photographs here. So this is from Derby Road on the Bootle branch, looking into the site. So you can see Regent Road in the distance there. This is where the double track section converges into a single line. So it's this piece of single line that was causing the capacity issue that we needed to redouble. And there's a set of train operated points here, hydro pneumatic points. So once we're round the corner, this is Regent Road now, travelling sort of up and down the docks, and you can see the slightly dilapidated state of the single line section. Running alongside that is a steam pipe that actually feeds steam to various facilities in the depot. There's basically a power station in the middle of the port, generates steam, and then it transmits it along this main pipeline. And then the bottom picture, this is Strand Road. So at the other end of Regent Road here, basically the extents of our site, we've got another level crossing at Strand Road. So this is looking back down towards Derby Road direction. So essentially this is where our double tracking ended. We tied into these two existing tracks here. Just a few facts about Port of Liverpool. It's the 4th largest port in the UK in terms of tonnage handled per year. Just to put today's sort of throughput into context, during the war, 1939 to 1945, a total of 70 million tonnes of cargo were handled at Liverpool. And today, with it being the 4th biggest port, they actually handled 31.1 million tonnes, or last year, that's the tonnage handled. So although the port itself and the rail network is a lot smaller than it originally was, due to efficiencies of containerisation, basically, we've managed to vastly increase the throughput at the port. We've got some historical pictures here of freight traffic. So the key commodities that the port deals with are coal, containers and bulk materials. So just looking at the coal traffic there in the top left, basically coal by rail pretty much started in 1882 when the first coal-fired power station was opened. At Liverpool, between 2014 and 2015, there was a sudden contraction in coal traffic. So 9.4 million tonnes were shipped out of the port in 2014, and by 2015 that had dropped to 2.4 million tonnes. And the coal train traffic actually ceased in May 2015. So that's basically when the coal facility was converted into biomass. So looking at the biomass traffic now, you can see on the left there, specially made wagons to transport the biomass material, more of that later. And then on the right, we've got basically 3 silos. Each silo holds 33,000 tonnes, giving a total storage capacity at the facility of 100,000 tonnes of biomass. Right, so on to scrap metal then. So European Metal Recycling, a couple of pictures of their recycling sidings here. They handle that company recycles 10 million tonnes of ferrous metals and other metals per year, anything from warships to drink cans. And from Liverpool, they ship out 1 million tonnes of scrap per year. Just an environmental fact about EMR, they are actually aiming for net carbon emissions by 2040 by various measures as well. So that sort of falls in with the theme of the talk as well. The trains, you can see there, bottom right, trains generally out of the port and into the port consist of 2 rakes of 18 MBA wagons. So that's the wagons that EMR currently operates. So MBA wagons, or commonly known as monster boxes. Each box carries a 70-ton payload, and typically a train would carry 1,300 tons of scrap metal. So if you look at how the biomass actually gets from its source to Liverpool, it actually comes from Baton Rouge in the United States, Mississippi Delta. So this is where the pelleting plants are located. They load the pellets onto typically 50,000-ton cargo ships. I think that the largest ship to the UK from Baton Rouge today was a 62,000-ton delivery, which went to Port of Immingham. So Drax Power Station that basically fed with biomass from Liverpool and Immingham. But generally, the ships to Liverpool are 50,000 tons. And then onwards from Leeds to Drax, the power station where the biomass is burnt, map on the left here basically illustrates the, oops, lost my slide, yeah, slide here. I can find my pointer. Yeah, so from Port of Liverpool, it's a bit of a tortuous route, basically shown by the blue line here. So makes its way over to Drax, a total distance of 180 miles. Now, there have been campaigns for, well, it's basically called CellWrap, to reinstate the section of track which was closed in 1970 between Colne and Skipton. I believe that was going to form part, or will form part, of the Northern Powerhouse. And then that's key to forming an east-west spine for freight traffic, actually. So if and when that link is reinstated, it will provide a significant benefit to the biomass traffic. It will, shorten the route over to Drax. If we look at the wagon fleet that's been manufactured for the biomass, basically these are Tafus wagons, 18.9 metre long twin bogie wagons, 113 metre cubic capacity. There's a fleet of 225 of these wagons manufactured for Drax, dedicated to biomass transit, designed by Ricardo Rail, and they started to enter service in 2014. The Liverpool to Drax trains are 17 trains a day, each train typically 25 wagons. Now, biomass, unlike coal, must be kept completely dry at all times, for the system to work and for it to burn cleanly at Drax. So these wagons are quite ingenious. They've been designed with top covers, and these are automatically opened on approach to the hopper by a system of magnets that are fitted to the wagons and fitted line side. So they will activate the doors, open the doors, the train's pulled through the hopper. Once the wagon is clear of the hopper, another series of magnets will close the doors. So quite a clever design, really. Just a few key facts about the biomass facility at the port. £100 million scheme, constructed 2015 to 2016. Up to 3 million tonnes of wood pellets can be handled per year from North America. The pellets are actually a low-grade wood which is chipped. I think the best description, if you think of like livestock bedding and what you'd see in a horse stable, sort of wood shavings, it's that sort of material. The terminal itself includes a loading facility, 100,000 tonne storage capacity from the three silos that you saw in an earlier slide, each silo 33,000 tonnes. And then the freight trains, typically 25 wagons that we just covered. And this scheme was actually great for on a job creation front. 50 jobs created at the terminal, and a further 300 jobs are estimated to have been created in the whole supply chain related to the biomass industry. Right, so biomass combustion then, the CO2 released is offset by the CO2 absorbed from the atmosphere while the trees are growing. Well, that's the theory about it anyway. So when people say that burning biomass is carbon neutral, that really puzzled me, because I couldn't really see how on earth could that be carbon neutral, transporting material basically 5,000 miles across the world and then burning it in furnaces. It just didn't make sense. But after doing a bit of research, I found that the EU actually measure carbon neutral and renewable. It's measured at the point of combustion, which that sort of explains it. So it's not taken into account the whole supply chain, all the diesel emissions and everything else. I won't really go into that because I'm not an environmentalist, but I felt a little bit deflated when I read that, really. Anyway, biomass at Drax now accounts for 12% of all the renewable electricity generated in the UK. It's supposedly 80% less CO2 emissions compared to coal, and the whole operation sustains up to 20,000 jobs. Right, so if we look at biomass at Drax then, so Drax, it's the largest power station in the UK, located next to the South Yorkshire coalfield. Once upon a time there were 56 collieries there, hence the reason why Drax is where it is. The last deep mine in Yorkshire, Kellingley, closed December 2015, so Drax has been changing over to biomass over the last 2 decades in anticipation of this. In 2003, they converted one of their 6 generating units for burning biomass, which then was locally grown willow. By 2018, 3 of the generating units were converted to biomass, and by last year, the 4th unit, so 4 out of 6 units now burn biomass at Drax. 77% of the energy they generate is classified as renewables, and that's a total of 12% of the UK's total renewable energy. So here we've got, this is Coal Road 1C. The tracks at Liverpool are still named as they were when this was a coal handling facility. So this is Coal Road 1C, and you can see there in the foreground, that is biomass spillage from one of the wagons. So it just gives you an idea of what the biomass looks like. It's almost like a sawdust. This is the loading hopper. So the trains, they pull through here at, I don't know, 2 miles an hour or whatever it is at crawling pace, and they are continuously loaded from the hopper in this shed here. And you can see that, yeah, aerial view on the right there as well. So system of conveyors come from the storage silos, fill up the hopper, and then discharge to the tops of the wagons. Now we've got another view of the 3 storage silos at Gladstone Dock and the conveyor system. Right, so after all that, we get on to the actual track redoubling. So basically grip 2, grip 3, option selection process. I'll describe that in a minute. The diagram on the screen now is basically the track layout as it was before we redoubled it. So as I mentioned earlier, you've got the up and down goods, the twin track section, set of train operated points leading around a very tight curve here, across Regent Road, and then alongside Regent Road where the track doubles back out again. So the whole crux of the remodelling was to double this single line section here and provide functionality for parallel moves. So basically the port wanted to get trains going in and out of the biomass facility and be able to have traffic going in and out of the container terminal at the same time to really up the capacity. So just a few aerial shots of the existing layout again here. You can see the double track section, train operated points, tight curve, former Regent Road level crossing, and the steam pipe following Regent Road. And then just looking in the other direction, single line track following the steam pipe, or sandwiched between the steam pipe and Regent Road, Strand Road level crossing. So this was the limit of our renewals. Picture of the hydro pneumatic train operated points here. And this is the curve leading from Regent Road, looking around to Derby Road. This is the former Regent Road level crossing, so check rail both sides, really tight radius. It was, I think we measured that as a 118 metre radius at one spot, so it was really tight. The trains really screeched around here. The level crossing surface was uplifted some years ago because the port were having issues with HGVs actually flipping up the Biomass panels on this, so they just decided to close the whole thing off and lift out the panels, and it stayed in that state for a number of years. And then this is a picture where the track doubles back up, looking towards Strand Road. So yeah, basically this. So the purpose of the whole track remodelling was to vastly increase the capacity. So pre this project, there was basically 1 train per hour capacity in both directions. The double tracking actually provides 2 trains per hour in both directions. The port's aspiration was to have 38 trains per day in both directions by 2043. And there is potential capacity at Earlstown in terms of signalling on the Bootle branch to allow up to 48 paths per day. This is just a snapshot of the EMPTA, or equivalent million gross tonnes per annum assessment that we did. So with there being such a vast increase in freight traffic projected, we thought we ought to do an assessment to see what impact that might have on the track categories. When we actually looked into it, we found that the published tonnage and track categories didn't appear to have changed since the coal traffic was at its peak. So what we found was, with taking out of the picture the coal traffic and bringing in the projected maximum biomass traffic, well, all the port freight traffic up to 2043, we found that actually the track categories and tonnages as published were still right. So we took out the coal and brought in the biomass, and the net impact was virtually nothing. So we assessed the tracks to be both category 3. Right, so during the optioneering, Grip 2, 5 initial layouts were identified, options A to E. During Grip 3, option E was developed and another 4 options were investigated. The final Grip 3 option selection process, 3 optimized layouts were considered. So before we got to the end of Grip 3, we'd actually whittled all those other options down to 3 preferred options. These were labelled options 1, 2 and 3. So this schematic here illustrates these options. So option 1, the new track in red, the green underneath is existing track to be removed. So where the train operated points were in the single track section, option 1 was proposing to remove the train operated points and twin track by laying a new track along the EMR access road. So this will be straddling that steam pipe which goes down the middle there. That was option 1, and that was a reserve option really, because we were always very nervous about the multitude of buried services that were probably, or we suspected will be present in Regent Road. So that was an option to try and mitigate the impact on buried services. Option 2, right, this one, it's quite similar to the actual option that was installed, but it's got a crossover down here, pretty much where the train operated points were. This wasn't very preferable because these are hand points in the port. So basically, network rail boundary here, everything else is port owned and operated. So that wasn't ideal because the shunter's cabin's right over here, so it just increases the distance he's got to walk each time he needs to throw the points. So the preference was to keep all the S&C here, right by the existing shunter's cabin at Strand Road. They actually have to be motorised. Yeah, and those, John's just reminded me, these would actually need to be motorised there. So obviously the port didn't want to entertain taking on motorised points, and that would just create a bit of a nightmare in terms of network rail and port boundary signalling and everything else. Option 3 is the actual option that was implemented at the end. So this was a really good option. It sort of ticked virtually all the boxes. The S&C is all compact, and at the Strand Road end, it allows your parallel moves into and out of the container terminal and the biomass facility. And I think it's fair to say the only major drawback with this is it needed to take a slice of Regent Road off. So this new track's going on the road side of the existing single line. Now we anticipated that would probably cause havoc with buried services. I don't think it was as bad in the end as well, my colleague John will come on to that later on, but I think we got through it fairly unscathed really, so it all worked out fairly good. This is just to illustrate the sort of the option selection process. We just scored each option basically, and it told us what we already knew. You know, option 3 was the preferred option. Just looking at the S&C design then, we actually tried to make use of serviceable components as much as we could. We did find that very hard to get hold of. There wasn't really much on the National S&C stockpile that we could use. We've designed it all as standard BV8, CV9.25 units, and we managed to get 2 sets of serviceable switches and 4 serviceable cross rails, serviceable check rails off track work. That's all we could have. That's all that was available. So we made use of those and sort of integrated those into the S&C layouts which Trackwork manufactured. So you can see we had the crossover that I've just shown, and then 2 back-to-back turnouts. Basically, it's all standard, absolute standard jointed CEN 56 S&C on timber bearers. Absolutely nothing peculiar about it. Apart from the serviceable switches, they actually had cut down stop fronts. So we put the 2 serviceable switches on the extreme ends of the S&C layout. Reason being, in the middle between the crossover and this layout, we had back-to-back stop fronts, so we wanted to keep those absolutely standard. So we've just got a few historical photos here of Regent Road level crossing. So on the left, this is what it did look like up to a few years ago with the Biomass panels in it. You can see a much older photograph top right there, where it used to be, you can actually see the original 2 tracks. So essentially we were redoubling the layout. It used to be 2 tracks at one point. It's been rationalised down to 1 in British Rail days, and then we've put the 2nd track back in. And then this photograph down here is summer last year. I mentioned earlier, very tight curve, check rails on both sides, timber sleepers, CPAN 6 base plates for the check rails. So the initial proposal as part of our works was to put a brand new level crossing here on Regent Road, and the selected preferred choice was the Edelon Cedra system. Now, we did have Edelon Cedra provide a talk to the PWI section a few months back, so I won't go into too much detail, but basically this system, I think it's really good. It consists of precast concrete panels, so it's like a modular approach, and 3 metre long panels. You butt them all up, and then you basically have a groove here which can accommodate the rail. So for this job, they actually designed the units to accommodate the check rail as well. So the groove was wider, basically on the inside of the curve, so it could fit in the check rail. So that assembly is dropped into the groove, and then the whole thing's flooded in this corkalast material, which holds it all rigid. It's basically like almost like silicon rubber, I guess you'd describe it. So that is just the plan view of the Edelon Cedra system there. I think there's 37 panels, each 3 metres long. You can just about make out Regent Road here. So the design sort of catered for a 2 metre wide footway and a 7.3 metre wide remaining carriageway there. This particular item had to get de-scoped in the end because of budget constraints. It was proven to be a bit more expensive than the project had allowed for, so we actually ended up putting a conventional rail type system in the end. Right, so on the S&C, all the point ends were fitted with the Racor switch stands, which seem to be the go-to hand point system these days. I think freight operators really prefer these because they're much more ergonomic, and in terms of these sort of manual handling considerations, they're just better all round for the shunters. We at the port did ask for the targets as well. These targets here, those haven't actually been installed because we've stumbled on that a bit. The Racor switch stands are all fully Network Rail approved, but unfortunately the targets or the flags aren't, so we haven't been able to sort that one out yet. I think if the port really want that, it might be something they might have to provide themselves. I don't think it's been fully bottomed out. And just a bit on irrigation standard variations. We had a few on this site. It's a bit of a peculiar one. So although we've assessed it as being track category 3, and it's currently published as Ram Smooth category 2. if we refer to the track standards, we're not really supposed to be putting hand points in there with, you know, timber bearers and full depth switches. So we managed to apply for derogation because the S&C is actually on the port side of the boundary, although albeit classified as track category 2. So you know, these were just managed with standards variations. And again, SEN 56 rail in track category 2, when you refer to the standard, it is actually asking you to consider SEN 60 rail and welded, not jointed. Back-to-back stop fronts in the middle of the S&C layout. We had basically the stop front joints were coincident, so 6.14 metre toe separation. When you look in the track design handbook, that is actually shorter than the preferred toe separation. So we got derogation for that one really easily. We just basically checked for buffer locking there. That was the only consideration. It was absolutely fine with them being C switches. And the only major issue we had with buried services was at Regent Road, where we had some quite shallow services to contend with. So we had to reduce the ballast depth to 200 mil there. So 200 mil ballast on a category 2 track. It was only over a localized area though. So again, that was just managed by achieving derogation. And just a summary of the challenges that we're up against: very tight financial constraints and a tight programme. Buried services and utilities that I've mentioned. The curve around about the Regent Road area, 155 minimum radius. So we basically had to check rail, gauge widen and pre-curve the rail through that section. The check rails were achieved by using C pan 6 base plates, so you know, very sort of well-established base plate. There's an REPW drawing for it. We could put it on the timber sleepers, so that was ideal. So we just basically replicated the existing track construction there, albeit just a check rail on the inside and not on both rails. There was an adjacent warehouse development which I touched on earlier. Marsden warehouse, so there was a bit of a design interface with them. They were building a retaining wall next to their site so they could level off the site, and so you know, that needed some quite close coordination to make sure that their retaining wall didn't impact on our safe access width around the curve there. And the existing drainage system, you know, it took us quite a while to get to the bottom of exactly what the existing drainage was doing. It was a bit hodgepodge, a bit hit and miss, so we did various drainage surveys. We managed to suss out in the end where it was all falling to and where it was outfalling to, and we designed our new track drainage system on the twin track section up to Regent Road to tie into that quite well. And right, I'll just hand over to my colleague John Hayes now, who's going to talk about some of the sort of more engineering management type aspects of the job.
Cheers. Hi everyone, so yeah, my name's John Hayes. I was the engineering manager for design on the project, trying to help us get it delivered. So I just wanted to spend 5 minutes, because I appreciate we're running out of time, taking you through the multidisciplinary aspects of the scheme. So the kind of the first major hurdle we had was trying to achieve an early win, if you like, for the project by undertaking an enabling stage for signalling. So the commissioning of the project was actually September 2021, but in September 2020 there was an opportunity for a relatively large closure, like a week closure of the port because of maintenance of the biomass facility. So we took advantage of that to achieve some early goals for the project by decommissioning the Regent Road level crossing signalling equipment, which was one of the major goals of the project, and also a major kind of operational constraint on departing freight trains being able to get up to speed. Just on the Bootle branch, there's a 1 in 62 climbing gradient going up to Bootle Junction, and you know, a heavy freight train needs a good run at that. and one constraint that they had, if you see the bottom left photo, there was a stop board that they had to stop at, and that was because of the level crossing, and was kind of a historical feature from when the level crossing was a functioning level crossing on a public highway. So what had to happen was that the driver would have to stop at the stop board, get out of his cab, open the little box that you can see with the yellow sign on it, observe the line clear indicator, observe the level crossing indicator, and then press the plunger, and that would then deploy the yodel alarms and the wigwags on the level crossing, close it to traffic, and then he could proceed. And all of that takes quite a long time, and also means that the train is having to start from a stop at that point rather than starting at Strand Road a lot further back. So what we did was, in association with actually legally closing the level crossing, so we revoked the level crossing order, and then decommissioned all of that equipment, removed it, and just replaced it with a lot more simplified equipment, including the points indicator that you can see in the photo here, and also removed the line clear indicator, which was in this box, to Strand Road, next to where the PIC operates out of his cabin. So you can observe that from there, and that was a major early win for the project. Signalling for the final stage was actually fairly simple in the end, because we selected the right option, option selection stage. So we made life easy for ourselves by going for hand points rather than point machine operated points, which would have needed a signalling system to work with them and interlock everything. So all we actually had to do was recover the train operated points and the detection that's associated with it, recover the points indicator that we installed at the enabling stage, get rid of a couple of track circuits that were related to the level crossing and no longer required, and then just try and rationalize any other kind of life expired or in poor condition equipment, such as load cases and things like that. We also put a replacement indication panel in Strand Road cabin, which is on the next slide, and replaced permanently the line clear indicator with an LED replacement. The photo at the bottom just shows, it's not very exciting, it's just some signs, but the left-hand photo is the stop board for entry into the port before we started doing anything with the telephone, and you can see that it's actually held onto that pole by a shoelace. Actually, it's just dangling there, so it needed a bit of work. So we replaced that at the enabling stage with a nice new sign with the PIC number on it, new speed board, proper stop board signage, and then at the final stage the telephone disappeared and we replaced the telephone with a GSMR code that the driver dials into the console in his cab, basically. Just a few more signalling photographs, so just an extract from the scheme plan at the top, which you can see is relatively simple. The indications panel in Strand Road cabin, you can see the old one on the left with the fly swatter hanging in front of it, and it's all kind of drawn by hand. Is a little bit in need of a bit of love and attention. And then the new one on the right, which is all singing, all dancing, and nice and clear for the pick to use. The line clear indicator, bottom left, you can see the interim one on the left there, and then the final one, which is just extremely simple LEDs, green for line clear or line open, red for line blocked. And then there's just a before and after. It's not before and after actually, no, it's just showing the limits of the signalling from the Bootle branch. That photograph is looking towards Derby Road Bridge, and the IRJs in the foreground are the kind of limit of the network rail track circuits. And then the photo on the right just shows one of the new LOC installations. Telecoms was actually a lot of talk about telecoms on the project, but in actuality we ended up with a relatively simple solution, which was good. So bottom left, the photograph there, you can see the historical defunct concentrator that was in the pit cabin, and you can see that I think there are 10 telephones around the port. Basically, I think 8 of which weren't connected anymore. A couple of network rail related telephones. That was removed. No one would admit to being responsible for the maintenance of it, either network rail or Peel. So that went and was replaced in association with the use of GSMR instead of line-side telephones, with just a direct dial telephone to Sandhills Signalling Control Centre and then an outside line ETD telephone. And that's basically all they need. And a couple of other bits that telecoms are responsible for, the cable route you can see there, and GSMR signage. We also had some 650 volt signalling power to deal with. Before and after photos here are quite interesting. So you see the bottom left photograph, there's a load cabinet there, which is exactly where we wanted to extend the twin track down here. We had to move that across the track to the opposite side and do quite a bit of other work to clear this section of cess to make way for the new track. So that's where the drainage originally ran, that's where the cable route ran, and then these lokes as well. So all of that had to be transferred onto the other side. So we've got a new cable route on the other side via a new UTX that went in up here. We rerouted the drainage onto that side and then relocated those lokes across, and that required us to basically reroute the signalling line side cable, the 650 volt power cable and the telecoms cable in new troughing on that side and call in at these new cabinets as well. This one here is a new FSP cabinet, so functional supply point. So instead of the classic signalling loke where you'd have the power as a section within the cabinet, the FSP is a separate 650 volt power cabinet that is the responsibility of the E&P maintainer in Network Rail as opposed to the signalling maintainer. So it's a nice clear division of responsibility of asset maintenance between the two. So we ended up putting 2 loke suites in with an FSP and a signalling loke at each one. And then the bottom right photograph is the loke that remains, which is covered in pigeon droppings under Derby Road Bridge, and we tied into that and basically continued the power cable from there. We also did civils, drainage, highways and geotechnical design with such things as cable routes, UTXs, URXs, lots of utility ducts under the railway as a UTX on Regent Road, loke and FSP hard stands, track formation design, signage, barriers and curbs along the edge of the road where we've basically taken a strip of Regent Road and needed to reinstate a new barrier between the railway and the road to prevent kind of vehicle incursion onto the track by HGVs. So all of that was part of the multi-disc design that we did, although some of that will be delivered by Peel themselves on the highway because they prefer to do that. So utilities. So Les said that we came out of this relatively unscathed. I think Les did. I'm definitely scathed by it. It was it was pretty tortuous. I mean, if you look at the image in the middle at the bottom, we did GPR surveys and lid lifting and that kind of thing to work out what services were there. And I think at one point we had 65 instances of existing services clashing with the track route. So we had to identify all of those, try and eliminate them from our inquiries systematically. Some of them were redundant historical services that even Peel as landowner didn't really know about. Some of them were third-party utilities companies. In the end, we had to deal with Scottish Power Energy Networks because there was a 33 kV and an 11 kV cable at Regent Road level crossing. There were 2 UU water mains, one of which we had to remove, and there are diversion works actually ongoing for that through ducts that we put under the railway at Regent Road. There were sewers. You can see with this image bottom left, there's a sewer running along the middle of Regent Road that we crossed, that we had to do an assessment of. That's a Victorian brick egg sewer, as they call them. This image here, that's just a slit trench that was done across Regent Road, and you can just see what you're dealing with, just loads of services, old and new, and we had to try and have a strategy for dealing with each of those in terms of working proximity or diversion to avoid clashes with the formation. The one bottom right is the Cadent gas main, which was round here. There was actually, unluckily, right on the sleeper end, there was a joint between an old cast iron gas main and a new plastic gas main, and we needed to move that joint basically further away from the railway. So that was a bit of early works that Cadent Gas had to come in and do. And then last but not least, this diagram here, I don't know if you can see it, it's quite small, but another assessment we had to do, there's in addition to the kind of the shallow depth United Utilities services, there's also the MEPAS estuary pollution alleviation scheme, or MEPAS sewer, which runs at 12 meters depth, and it's 1.65 meter diameter tunnel bored sewer that is basically the sewer outfall for the whole of Liverpool pretty much, and that runs from just north of Seaforth all the way to Garston along the coast, and that is just a massive beast of a utility. Luckily it's so big that putting a little track at the top didn't really worry it. So we did an assessment that proved that quite easily, and we carried on, and you were happy with that. Last one from me, so that just the property maintenance boundary change, land acquisition. Network Rail purchased a strip of land from Peel Ports, and sorry, someone's just walked in. Yeah, the one key aspect of this was having to move the maintenance boundary. So Network Rail actually purchased a strip of land from Peel and then long leased it back to Peel Ports. So you can see here, this was the strip of land which was purchased kind of to follow the footprint of the second track. And then this is the lease area, like a 100-year long lease, I think. And then one of the major benefits for Peel is that the maintenance boundary, which is currently at this point here, gets moved to the IRJ limit here. So Peel are responsible for much more of the track work. They basically inherit it from the project and carry on with the maintenance, and don't need to kind of engage with Network Rail to do things near the track, which is a major benefit. So you can see on the diagrams here, that moves from there to there. So that's that from me, Les. Thank you.
Conscious of the time, I'm just going to whiz through these last few slides now. So these last few slides show the works during construction. So this first one is looking from Strand Road through the S&C area towards Derby Road, or towards Regent Road crossing. The S&C for this site, although it's hand points jointed on timber, it was actually installed with the Keir-off crane during a blockade of the port's track. Right, next slide. This is the curve on the approach to Regent Road crossing. So this is the tight 155 metre radius curve. You can see here on the right, this is the start of the check rail at the Derby Road end, ready to go in. There's obviously what the upline's been relayed already. We've got the new formation prepped for the down track to go in. It's all laid in pre-curved panels, so that the panels are all prefabricated and numbered up. So it's just basically putting a jigsaw together. You can see a switch panel there on the left with the Keir-off crane preparing to lift that into place. Well, just unloading and ready to lift in. And then on the right there, Keir-off crane in action, dropping that switch panel in on the prepared formation. Again, you can see here the S&C with the rack or switch stands. Top ballast has just been dropped. Obviously needs all boxing in and tidying up, but it just gives you an impression on the right there of the new S&C layout with the crossover and the two back-to-back single leads. So we've got here a picture. This is Strand Road looking down towards Regent Road again. This is at the limit of Renewal actually, so you can see where the fresh ballast finishes. This is the new installation joining into the existing track at the Strand Road level crossing. A couple of hollow bearers here for the telecoms cables crossing the two new tracks. And then a view down Regent Road. So you can see here we've actually cut the edge of the road off. It was a really wide carriageway previously, coming pretty much right up to the cess of the single track. So the single track's been relayed, the new upline's been put in. You can see all the S&C there, and a big slice of the existing highway has been taken off, which is where we encountered all the services issues along here that John's just mentioned. This is a before photo here on the right, so you can see the difference here. Regent Road edge right up to the single track, so that was right over here. This is the curve at Regent Road again, so you see the check rails on the inside, CPAN 6 base plates, timber sleepers, gauge widening, flangeway widening, pre-curve rails. That's a before picture there, quite a grotty piece of track. Notice the site, this is the Marsden warehouse development site, so that's not actually kicked in yet, whereas by the time we came to do our track renewal, the warehouse was substantially complete with the new retaining wall there. This took some, as I mentioned earlier, some quite close coordination, because at one point their retaining wall was proposed far too close to our track, so we had to, you know, a series of meetings, we managed to negotiate, and that was pushed back to give us a 2.2 wide cess to allow for the, you know, the throws on the curve. It still gave us enough room for a safe cess walkway. Again, this is the same curve looking back towards Strand Road, so you can see the warehouse development there, the two check railed curves, and the S&C in the distance with the steam pipe there. That's a close-up of the CPAN 6 base plate arrangement for the check rails. And again here, this is a before picture taken pretty much at the same location. So you can see vast improvement. And new access points signage at Regent Road level crossing. Again, you can see the new warehouse facility there, and both tracks installed. All the ballast has been regulated and boxed in. Nice tidy site. The new suite of lokes here on the left-hand side. This is the existing photo before the works were undertaken. See the standard sort of grease pot here. We actually replaced that with a new electric type, Whitmore type lubricator to cover the tight curve. So there's one of these at each end, so that the direction of traffic on the down is into the photo, so it picks up the grease, takes it around the curve, and then on the up line the traffic's coming the opposite way, so the greaser on that line, same type, is at the start of the curve around the corner. This is the Derby Road end limiter renewal. We retained a couple of existing adjustment switches, so you know, we designed to actually retain those. Didn't want to mess with those. It's just adding unnecessary extra budget and extra work if we were to carry the renewal through to that. So going into the picture there, into the port, that's all jointed track, and going out of the picture towards Derby Road is all CWR, hence these two adjustment switches. And that's looking towards Derby Road Bridge out along the Bootle Branch network rail. Before and after. Doesn't look vastly different there really. This was a tamping tie-in basically, just a bit of tweaking to the alignment. And that is the end of the presentation. So thank you very much for listening, and we would invite any questions if anybody would like to ask any. We will do our best to answer them.
Thanks a bunch for that, Les and John. There is a question in the chat just from Mark Campbell. What is the background to the closure of Regent Road, level crossing to road traffic? Has the road been rerouted?
Do you want to answer that, John?
It's actually, it was originally the old dock road. It was an A road at one point, Regent Road, and it just got closed off when Peel Ports actually inherit or purchased Liverpool docks from the Mersey Docks and Harbour Company, and basically the boundary ended up putting a gate across Regent Road just south of the level crossing, so it just went from public realm to port infrastructure basically, and was no longer required, and it's not, as a highway route, it's not actually required for traffic moving around the port. Peel Ports can do without it, although there is passive provision for reinstating it as a port controlled level crossing in the future, but that there isn't the money for that at the moment. So yeah, it's just pretty much because of the you know, the removal of the level crossing order, it's actually fenced off at the moment, so highway traffic can't go across there. But yeah, they could put a level crossing back in the future. Is that okay?
It's got that. Just got another question here from Steve Long. Just regarding the geometry of the biomass wagons, just because the length of the wagons themselves extend quite a while over the bogies, did this require any special consideration for clearances, and did it affect the design?
It was certainly a consideration. So as I mentioned in the talk, we did check for buffer locking on the back-to-back stop fronts, 6.14 metres, which was actually a factor why we went for C-switches. You'd normally expect, you know, as a go-to layout for sidings and depots, you'd usually go for a BV8. Well, we actually decided to go for CV9.25. And one of the reasons was to make that buffer locking check work. So it was getting a bit too tight with BV8 units. And then also on the Marsden warehouse development, we had to take into account the centre throws for the wagons and the end throws when considering the required cess width for continuous position of safety. So, you know, with it being such a tight curvature, 155 metres, it wasn't sufficient just to go with the standard 2 metres. We had to widen it out to allow for those vehicle throws.
Oh, that's interesting, that. Just give it a couple of minutes, see if there's any more questions roll up. No, it is interesting to see, because I was out on the biomass terminal up at the north end a couple of weeks ago, doing some of the civils works on a level crossing relay that they had in mind. So seeing the talk like this on the wider scheme that Pillpots have got in mind is definitely interesting. Another thing I thought was quite key was the fact that the carbon measurement is the point of combustion, Les. I thought that was probably a preferable measurement metric for some.
Yeah, it's a bit of an eye-opener, that, because I almost felt a little bit conned when I read that, you know, the assumption the EU make is that it's carbon neutral at the point of combustion, and if you're burning biomass, the assumption is that the trees that replace the trees that were cut down to make the biomass will absorb the same amount of carbon dioxide as released in the combustion process, and it doesn't take into account any carbon emissions from, you know, the actual mode of transporting the material halfway across the world. So I think there's a fine line between the word renewables and carbon neutral. This biomass is a renewable, but it's not, you know, if you consider the whole process from start to end, I don't think you can claim it's carbon neutral.
It probably calls into question a lot more about carbon footprint, though, doesn't it? You know, we're trying not to open a coal mine in the UK for coke production for steel manufacturing, but we're happy to ship it in from China. So how do you know, it makes that quite a difficult argument for them to actually demonstrate that moving it from Cumbria to the rest of the UK is better if they're not taking into account that transport element, which must be massively different. But yeah, very interesting.
Any other questions from the group? Right, well, Les, John, that was an excellent talk, very informative. Can I just ask everybody turn on our mics and give our thanks in the traditional PWI fashion?
Thank you very much.
Thanks.
Thank you both.